places. Other places is the basic formula. What is that? VQ over IT. That special place here, that VQ IT equivalent to that one. Yeah? So that's not one case. So try look at the circular one. Circular one. Now got V there. So maximum is here. Tau max. What is tau max? Diameter there. And then you can remember that? Draw a line there. And then the area. What is the center of the area? So what is tau max? Remember that? Tau is equal to VAY bar divided by IT. So let us do that slowly. Okay? Let's do that slowly. You see that one? Okay? Your V is V there. What is your area there? The shaded area. Half of circle. Full circle is pi r square or pi d square over 4. Half of that divided by 2. So pi d square over 2. Pi d square over 4 is circular one. Half of that must be pi d square over 2 and 4, that one. Pi d square over 4 is circular divided by 2. So you got the area. And then what is your y bar? So remember the centroid of that circle, half of a circular in your static. Please, somebody still remember not? What is your y bar? Centroid of half circular. Guys, in static, what's the value there? Hello? Hello, guys.
0.4R.
0.4R. What's the original formula?
4R over 3 pi. 3.
4R divided by 3 pi. So, what is y bar there? 4R. 4R is, R is diameter over 2, right? 4R. So, diameter over 2. And then 3 pi at the bottom there. So, that's your y bar. 4R, 3 pi. That is your area. That is your V. What is your I? Circular one. What is the I circular one? Pi d to the power of 4 over 64. And then what is your T? Your T there is your D. Yeah? I and T. And there's a D there. At the bottom there. So now, let us rewrite this one again. What do we have there? Pi and pi cancel out. Sorry. D and D cancel out. D square and D square here. Before we have a D square here. We don't have a D square there. D square. So what do we have there? This is 4 and 64, that's 16. What else? 2 and 2, 4. 4 and 4. Cancel out that one, this become 4. So what do we have there? V, pi here and D square. Pi D square over 4 there. Nah? And now what do we have there? Here we have a 4 and 3 there. 4 divided by 3. So what is this? Pi d square over 4. What is that? Hello guys.
The area.
Area. So what is that? So we have 4 over 3 V divided by the area. Remember that just now we have 1.5 V over A for the circular, for the square one. Now for the circular one, the maximum one, what is the maximum value? 1.33 V over E. This is what I mean 4 divided by 3 V over E. You see that? This analysis you can do on your own. You can double check on your own. You can check on your own. You can find the value on your own. And then you use your own formula there. The maximum here 1.5 V over E. The maximum here is 1.33 V over E. Starting with VQ over IT. Starting with VQ over IT. Okay? All this analysis you can do on your own. Why I don't have any special formula on some other places. Some other places is not critical. The critical is the maximum point. Yeah? And then, okay, that's the second things. Conclusion. And then, we go to the homework that we have done. I want to find the stress there. At V there. What is the stress at the tau at A that one? A. Or C that one. Tau C is equal to what? So, VQ over IT. So, what is the special thing there? The T. The T is not just that T, but that one plus that one. Go draw the line there together up until that one. So the line one is only that one. That's your T. Those are the conclusion you have to make to understand what is the formula VQ over IT. If you don't make conclusion, you're still arguing. Only this or together. You're still arguing. You must make conclusion from the ilmu. The ilmu is very simple, but require you to make a conclusion to understand of using the ilmu. So the same thing not with this one. The same thing not with this one. Same thing not? Same thing. So here, the T is that thickness plus that thickness. That area here, VQ over IT, Q is AY bar. So how do you find the A? You can find the area here. What is the Y bar? You can find the center of the Y bar there. The center of the area may be somewhere here. So you can find the value A times Y bar there. So you must do a lot of hypothetical question, okay? To understand this thing. And then what else that we have done? We have done also a cross-section that is not symmetry. So the first, you must find the position of neutral axis. Still, tau is still VQ over IT. I know that if the value of V like that, I know that this here must be 0, here must be 0. Yeah, how? This one up, increase there, and then there's a jump there, increase up there, and then something like that. You must be able to understand the system of graphing that when you see the equation, you can see the profile of the answer there. Why this go up and then go up here? Why go down there? You must understand why, the whole thing there. Why VA times Y bar IT, changing that value there. This is what the real learning, not just that formula. You must keep asking. I can only propose to you. You're not asking yourself, why is that, why is that, why is that, why is that? The ilmu is not with you. That's why a lot of people don't like me. Why? Because only the smart people like me. The smart people like to be scolded. The not so smart people, they don't like to be scolded. Because the not so smart people, who is in control? Nafsu, not akal. Nafsu don't like to be scolded. Smart people, who is in control? Akal. What akal? When akal is in control, he like to be scolded because if he cannot see things, some other people is telling him, you are wrong here, you are not good here, you are not good back, you are not. So somebody else is telling him how to improve. The reaction is different between smart people and not so smart people. And this is what I want you to learn, how to be a smart people. You are not that smart yet. Believe me. You must agree that you are not so smart yet. Only then you can train yourself to be smart. If you say you are already smart, you never appreciate what other people is telling you. This is a higher level, you know. This is a higher level of thinking. This is not 1 plus 1 is 2. This is not high school theory. This is education of higher level. So when you have a smart, intelligent in your head, you can work by reasoning. You can explain by reasoning. See that? It's all reasoning there. And how to develop this one? Keep asking, keep finding. Okay, that one. And then let us look at the relate. Now this is another thing here. Let us relate with what we have done with bending moment. Remember that bending moment? Look at simple case here. We learn about the sigma is equal to m y over I. This is last chapter, right? Now we learn about tau is equal to VQ over I T. Now let us look this one together to understand it. Okay? Look at this. See that? 100 Newton there. It's 1 meter, 2 meter there. So, if you draw the graph, draw the static there, this must be 66.6. This must be 33.3. So, you draw the V graph there. What do we have there? So, remember now? You up by 66, constant, and then you go down, and then constant up by 33, go to 0. This is minus 33, this is 66.6. That's your V graph. And then your moment graph at that point there, your moment graph there, maximum there, and go down back. What's the maximum value there? 66 times 1. So moment max is 66.6. The V here is 66. V here is 33. So, if you look at that one, where is the point of highest M? Only one place here. This is analytical thinking. You should be talking to yourself. Where is the point of highest V? Anything point from here to here. Ah. Why don't I put it up here? Why don't I put it up here? Why I put in the middle there? Because I still remember the cross section there. The highest is not at the top there, bottom, in the middle there. So the highest tau is here by the highest V. The tau is equal to VQ over IT. So tau max there must be V max, Q max over IT. So that here. So here and here. The other one is only here. Now the third question you must ask yourself. Where is the position? V and M is the highest one. Because this is together from here to here. So there's one point there. Where is the highest M and V? So the V is here. The M highest is here also. So now I want to look at the value. Now I want to look at the value. Yeah? Look at the value. Okay. See that? Let's say this is cross section is circular. Circular cross section there. Yeah? Yeah? There is a 66 times 1. There is a moment there. The moment there. And there's also V up there and then V down here. Yeah? V is going down there. The V. Yeah? Now look at the cross section there. Look at there's a moment at that axis. The moment is 66.6 Newton meter. Your V is also 66.6 Newton only. Yeah, your V is 66.6 now. In your moment, this is what happening. Now look at the side there. Look at the side there. This is element A. And look at the top there. See that the B there? Yeah? Just draw at the surface on the side and top there. So the surface there is very important to understand this one. See that? This line here and this line here is the surface where you calculate the stress. It's the surface where you calculate the stress. Because it is 3D there. Small element there is 3D there. There is a surface you cut there. Cut section there. But if you look at 2D, 2 dimension, you look from the top there, you got B there. Look from the top, you got B there. But on the right B there, right here, is the surface you cut. This is where the surface you calculate the value. So for this case, bending moment My over I there is pushing that surface. See that? Those are sigma there. You see that one? Sigma, that sigma is equal to what? My over I. What your M there? Your M is 66. What is your Y there? Your Y is distant from that axis to that one. Let's say the diameter is 20 mm. Diameter is 20 mm. So your Y here is 10. Your Y is 10, 0.010. And your I is 20 mm. Pi this to the power 4 over 64. So pi 0.020 to the power 4 over 64. You got a value there. And the value is tensile compression. Tensile compression, where do you look at? You look at the moment there. Moment is going like that. The top one is being compressed. The bottom one is being pulling out. Pulling out is tensile. Pushing in is compression. This is how you look at it. Are you with me, guys?
Yes.
So please push this value. What's the value there? Push the calculator there. What's the value? What's the value, please? Hello?
84.8 mega.
84.8 megapascal. 84.8 megapascal. That means compression there. So when you do a free body diagram later on, you cut everything there. Just you slice, just small element there. When there's a pushing there, the element is also inside here pushing there. That's the meaning of that one. You only calculate that surface. And then you know that value must be the same later on. That's later on. Okay? Starting with that surface. And then you go with that A. You go with A, the middle there. So that surface here is a red area here. That is the surface where you have the moment here is 0. My over I. If you calculate down here, the moment is the y. Y is on that axis. So 0. There's no normal stress there at A. But the shear stress VQ over IT is maximum there. I said it go down. So this is how you draw. This is how you draw the tau there. This is tau A there. This is sigma A. Due to moment. This is tau A. Due to V. So your tau A is equal to VQ over IT or remember that? 3 over 2 V over A. So what's the value there? 1.5 times V. V is 66. And then divide by the area. The area is circular one. What's the area? Pi 0.020 square over 4. So what is the value there, please? Push calculator. I want you to compare that sigma value and tau value here. What is the value there?
3
What is the value, please? Hello?
318 kilopascal.
318 kilopascal. Or you can write that one 0.318 megapascal. Can you see that? You cannot compare kilo and mega. You must put mega and mega, you can understand. That's how you compare things. Guys, 32 of you here, you must understand when you compare things, the root must be the same. This is what Bachelor of Science. That's what thinking skill teach you. Don't write kilo and mega. You write mega and mega, you can understand. See that? 0.3 and 84. What make this thing? The same thing. The 100 Newton here, put here, create a shear stress there. And then create a bending moment there. The bending moment create normal stress and shear stress. But the difference between normal stress and shear stress is very big. And that's why the tau from the shear load is very, very negligible. Very small. But from the bending moment, it's very big. Okay. Now, let us do hypothetical question. Nothing to do with this. But I want to get the same numbers. I want to get same numbers. What I want to do? I want to do this one. I have a rod here. Put axial loading. Axial loading. Let's try that. Remember we have learned the previous that sigma is equal to P over A. So let I use this size. This size and P that. that value is also 66. What do we have there? 66.6 divided by the area. Pi 0.0 square over 4. What is the value there? Little bit less than this one. What's the value there? Because this is P over A. This is 1.5 V over A. What is the value there, please?
Zero point two one two
To what?
megapascal.
To
0.212.
0.212 megapascal. See that? 0.212. So small or not? Small or not?
Yes.
Yeah. Now, let's conclude what we have learned so far. What we have learned so far in this semester. The internal loading, when we cut things, when we cut cross section, this is what? P. This is what? V. This is what? Moment. And this is what here? Torsion. There's only 4 internal loading. P, V, M, T. We have learned about this. Sigma is equal to P over A. We learned this one. But sigma due to P over A is quite small actually. And then we have learned about tau is equal to VQ over IT from this one. From this one. Small also. The value is small. And then we learn about the moment, that one. The value is big. And tomorrow, we start a new topic, chapter 5, we learn about T. So we learn about this one. What this one create a tau is equal to T up over J. Same with tau is equal to VQ over IT. But this one is smaller compared to this. This is much bigger. So moment and torsion is actually the greatest danger compared to axial and shear. Are you with me, guys?
Yes.
Today I'm talking about the analytical thinking, It's not copying and put numbers. You must try to develop your head going into this. Yeah, because you are not going to become a follower anymore. You are to become a leader. You are not to become a follower of an SOP. You are the one who want to create that SOP. Please take in mind that one. You must try to stand on your own. You know why? Why is the reason? I don't give a nice note. Can I give you, like other lecturer give a nice note to you? Can I give you? I can. But I don't want to do that. Why? Do you understand why? Do you understand why not?
Yes.
Because I want you to be independent. You don't learn by reading notes. You learn by critical thinking. You learn by discussion. What's happening during discussion? Question and answer. Tell you, in 1980s, 1990s, those are the peak, the best optimum student that we can have in the university. You know why? They are very independent. During the class, during weekdays, how many students come to my office? Every single day. in between the class, there's some student come, some come. Almost 40 students to 50 students come every single day. This I'm talking early 90s. When I was a young lecturer. 30 to 50 students, because in between class they come to class and ask that one, oh, this is what you told yesterday, this is correct now. They always ask to make sure what they're understanding on them. Up until 2000. After 2000, the number is decreasing. From 30, 40, become 20, and then become 10, less 5. Up until 2010, maybe once a week. One people is a week come. Not every day. 20 years back, 30 people one day. 1 week, maybe 150 students coming to the office to do the discussion, ask. Because the real understanding is during communication asking. When you read the book, the confidence is not there. This is what I'll do. You cannot come to my office. Even during the non-pandemic one, the last 3 years, nobody come to my office because they think they can learn. They think they have this computer, they have this phone in front of them. They think the ilmu is there. Ilmu is there, but the one who digests the ilmu is akal. Yourself. You need to communicate, discussion. This is not happening for the last 20 years. Degrading. For the last 10 years, it's not happening. That's why the intelligence, the akal, the making decision of the graduate is not as 30 years ago. And this is what I want you to do the homework. When you do the homework and right way you give me, I can communicate with you. You're wrong here. You do this one. So that one is to replace those communication. The most important thing is the discussion, communication of what the ilmu you have been doing. This is the trick that I give you the homework and you give it, return it back, and I comment on that. Because to get back the intelligence in you, to understand what you are doing, I ask you what is the reasoning. If I give everything to you in the notebook, just like my textbook, what's the purpose? You just reading again. The process of digesting is not there, just reading. Are you with me, guys?
Yes.
I hope you understand. As you get older, you understand all these things. I've been arguing about this for many years with my fellow friends. I remember in 2020, all the top officials in the university in UTM are making the hostel for the student inside the UTM. All the big hostel. I'm opposing to them. Before that, all the students are living outside in Skudai, Taman U, and Taman Seri Pulai, all this Taman around UTM, the one they are living outside with their friend, renting the house. So the top official university say, we build a nice housing inside so the student can study a lot. I said to them, no, you are killing the independence of the student. By living outside, they learn how to communicate with friends. They learn how to budget their money. They learn how to manage their time to go to class. They learn how to make peace if they argue with your friend. Kalau bergaduh, tahu nak baik balik. They learn how to divide their time. A lot of things they are learning when they are living independently, I said. What do they say? You're right. But we just want to make the house to make them easy. So they don't understand. They don't understand when comparing, you know. It's a problem. 20 years ago. They agree with me, but to make student easy. I said to make the student easy, you make the student not a better student. They don't understand that one. This is a higher level of thinking. Make the student easy, you create a not a good student. Where do you get this ilmu? From Rasulullah. Rasulullah, Allah make their father die, make their mother die, make his grandfather die, uncle die. Have to struggle not to become leader. Yes, that is the real ilmu. Not to give everything to your son, and then they are good. And this is what happened to a normal parents. They want to make a good housing for the student. To me, they are normal, even though they are big professors. To me, they are a normal parent, not on a higher thinking parents. Like your father, normal parent. They want to help you not? Yes. Higher thinking parent, leave you. Are you with me, guys?
Yes. Okay.
This is what happened. But I'm alone. Even now, I was being punished every semester. I was not putting the notes on my friends, my colleague, my boss. Why you are not putting the notes on the e-learning? Not just the student complain. Because I said if I put there, they just learn by reading. Can you use me, guys? You can have all those solutions there. Some other place, the same thing. What's the purpose do I put there? So for you to struggle to find somewhere else, that is the point that I want you to have. Because when you graduate later on, you are on your own. Nobody is telling you do this. Nobody. Okay, I give you some exercise. Okay, guys, thank you very much. Tomorrow we go into new topics, Toshin. So try to look on chapter 5 on that, on chapter Toshin. Okay? Toshin and moment is big things. V and P is small value only. Sometimes negligible. But from test purpose, we have to calculate on the procedure that we have done. Okay? So I give you some exercise to conclusion on this. So tomorrow, remember, we are going to a new topic, chapter Toshin. Okay, thank you very much. Assalamualaikum.
Thank you, Dr.